Let me tell you a little bit about my good friend Brad. Now, as you'll notice, there are two Brads at EstesGroup, and I got here first, so we call him Brad Van. Moreover, we're both Canadians, so when you say I need to talk to the Canadian Brad, that doesn't help anyone. Now they say I need to talk to the smart Brad, that sorts out everything. So what you're seeing here is a scene from a user group meeting with the Erie chapter that we had gave several months ago. Brad and me and the other Brad were there together, and Brad was giving a presentation on SQL Server best practices, and he had a virtual machine on his own computer that he was planning to use for the demonstration. Unfortunately, that his virtual box barfed on him, so what he ended up doing was given an hour just riffing on SQL topics. We had a great discussion, big open-ended discussion with the rest of the team about all kinds of subjects SQL based. But Brad never got to give that presentation that he had prepped for. So that said, one of the reasons for having the summit this year was to bring Brad in and give him an opportunity to give that presentation that he had prepped so diligently for. So with that, Brad, let me go ahead and hand it over to you.
Hello, everyone. Uh, so a couple of SQL people walked into a high-end restaurant looking to go for an expensive dinner. A couple minutes later, they walked back out because there weren't any tables. Um, anyway,
I loved it.
we should have canned laughter on these things. So, like, if you deliver a joke or a pun or something, it's not like crickets. At least I hear canned laughter.
Yeah,
Uh,
we should have some buttons.
um, So anyway, yeah. So to Brad's point, I was hoping at the Lake Erie users group to do a little bit of demonstration on SQL and go in and actually show. This is one of those things where it's kind of like Rubber Tree or Web Connect's presentation where slides just kind of don't do it justice. So I'm going to share my screen and so here is my dev box that I wanted to show several months back and couldn't because um, it just didn't work. So anyway, so this is SQL Server Management Studio. So to the Jedi Masters and the Jedi Knights out there, this is a tool that often you probably frequent. It lists all your databases. It started here, which is your SQL Server instance. This is the actual instance of your SQL Server engine itself that's running on top of the Windows Server OS that manages all of your system databases and your user databases. And I got thinking to myself, how can I get this presentation into 45 minutes? So I'm left with really surmising. I'm going to target several things here. Um, Inside of your SQL Server instance, there is a properties box that you can go to here. And what it does is it tells you your processors in that into, I forget his name earlier, was talking just before me here. Horrible. I was listening in, I promise. He was talking about NUMA nodes and such with memory and CPUs and that. Well, SQL Server is a server application that is NUMA node aware. So if it's on a virtualized environment, you can affinitize it with specific processors if you want. So if you have a host or a virtualized environment that spans a lot of different CPUs, you can dictate which ones are available to SQL Server to optimize its performance when it comes to RAM availability. Um, and I'm of a firm believer, no sense in starving SQL. You might as well throw as much RAM at it as you possibly can. In today's applications and the performance that everyone requires, the amount of data transacting, especially with P21 and the new web UI. P21 is not just made up of data tables that store your order records and transaction data. There's a lot of tables that store metadata on that data, your Dyna changes, all of those things that load windows and that store information in the database. And SQL Server itself stores data of itself in its own database, such as maintenance plan information, statistics, and stuff like that, which I'll touch upon here in a few minutes. So you can set all of these, you can affinitize how many CPUs you want to use, or which CPUs cores you want to use. And then you can get into one of the things that is of utmost importance on larger SQL Server deployments is that you don't install the logs, the data, and the backups, and the actual server instance itself on the same drive. I've actually worked with customers that were curious as to why their database was performing slowly as it was getting larger. And I said, well, it's because your log files, your transaction logs, your database files, your temp databases, and all the little components and intricate pieces to SQL Server are all sharing the same disk IO and drive space. This is a huge problem and a bottleneck for SQL Server, one that can easily be overcome by having multiple disk drives that the OS sees as disk drives, so that SQL Server sees them as separate disk drives, so it can do multiple operations without waiting for the operating system to respond in disk IO. So, and then the next settings that are critical here, and I touched upon this at the Lake Erie users group, is in SQL Server has the ability to do parallel operations. And I don't necessarily mean I can do multiple queries at the same time. I mean, it can do parallel computing on a large query that's being executed, that's a complex query, or what SQL deems as an expensive query that brings back many columns, many rows. There's a lot of filtering going on. There's a lot of operations in the SQL query. There could be variables, there could be parameters, all kinds of things going on in that. Querying tables that have many indexes. So you need to tell SQL, well, okay, if I run out of CPU power on one CPU, how long do I wait before I ask another CPU to help me out here? And I can actually break this query into separate pieces and go parallel with it and ask for more performance. So you have a cost threshold for parallelism, which is a time threshold that basically tells SQL, how long do I wait before I ask for help? And then you have the max degree of parallelism, which typically is how many parallel operations can I do at once? So usually you may or may not want to set that as the number of cores that you have on your SQL Server. You can try it. If you do, that basically tells SQL Server, don't leave it at a 0, whatever you do. That just tells SQL Server, I've got free reign of everything on the server. That can cause problems for the OS itself. It may or may not. It may cause longer wait times because now you've got multiple queries running and you've now starved the CPUs to say, I can use all 4 for this query. If it's a really expensive query, then that means all the other queries that were waiting behind are going to go into an IO wait state, and SQL Server will not execute them until the previous expensive one completes if you set it at the maximum. Now, I've got mine set at the maximum on my little dev box because I'm the only user logging on and I'm the only user running queries at any given time. So these are 2 of those settings where 40 to 50 is a good baseline to start, and somewhere between all of the cores you've got and probably half of the cores you've got. So if you've got 8 cores, maybe try it at 4. If you've got 4 cores, maybe try it at 2, and set those settings. And those are settings that don't need to be don't require the server being restarted. You can leave the server running. You make these changes, and it doesn't require a restart at all. So that's just touching upon a few things with that. And I've worked with a lot of customers that they say, well, our database is running super, super, super slow, and the web UI is running super, super, super slow. A lot of it comes down to the search pop-ups. So in comes a bunch of database statistics that SQL Server keeps track of for itself. And these are called the DMVs, the dynamic management views. And they're a great little tool in SQL Server that a lot of other third-party applications actually bolt onto to give you statistics. A lot of applications where you usually pay for them, they're not free, but they can help manage organizations that don't have that IT infrastructure to assist in managing. My theory, my take on that is you don't have to be a full-on database administrator to know how to interpret the data and read the data necessarily. What you can do is access the data, and one of the places to start is these are just some queries that I've written in the past when someone comes and says, well, I've got really, really slow performance and I want to know where my bottleneck is. So you've got the disk IO of the Windows operating system, and then you've got the disk IO throughput of SQL. So when you run a query such as this one here that's running against a DMV, now keep in mind this is on my little laptop running on a Hyper-V VM. So you've built some of these query statistics here that will tell you on my play database, I've got an average read latency of 71 milliseconds. I've got a write latency of 7 milliseconds. So I average of 71. It's telling me, well, I'm estimating I've got some words in here that say if it's between certain values that it's poor, good, very good. This is just a litmus test to do a baseline check of, hey, I've thrown all this disk at my server. I've got a fiber channel SAN, or I'm on fast disks that my cloud hosted provider has told me are like SSDs, or are they SATA drives? What is that throughput capability? This is one way to see if my database is actually performing without any significant bottlenecks. Then you can get into things like how long is my SQL Server waiting for IO? This comes down to the parallelism statistics and stuff where I've got expensive queries running that are returning data. Well, SQL can only process so many of those at a time before it starts to make everyone else stand in line and wait. So this is usually a run on demand kind of a thing. Some of these SQL queries you have to run while they're actually running. So it will tell you, hence the term dynamic management views. Another query that's I have worked on is this is a useful one here. I've kind of built it over time playing around with it. And I don't know if anyone is familiar. P21 has Epicor has a data dictionary that you can go up and look up columns and all of that. But you got to kind of, I got to look up this column and it'll tell me what other tables it in. It'll tell me, is it the primary key? Is it the foreign key? That kind of stuff. So this query here, when you run it, will tell you the relationship between the tables. What's a primary key? What's a foreign key? It isn't going to tell you what the indexes are, but it will tell you the column count on the table. It'll tell you how many rows. Everyone is familiar with the infamous audit trail table. We've worked with multiple clients that have had audit trail issues where it has just ballooned out to a massive amount of rows over time. And in retrospect, it ends up causing a lot of slowdowns. Because of the way the indexes are designed on that table, SQL Server tables are no different than a library. If I was walking into a library and I wanted to go find an article inside of a book, I'd start out with the Dewey Decimal System, look up where the book is, where is it in a row in the library, and then I open that book and then I look in the table of contents or the index to go find the article on a page number. It's no different. The same analogy for tables. Tables have indexes. Those indexes tell SQL where to go get the information in the least amount of time. For instance, if I look at the audit trail table, you'll see that it's got several indexes. Well, the audit trail table holds a lot of columns. And this here, non-clustered indexes typically are text. A clustered index will be something that is numeric more times than not. It'll be a UID field, a primary key field that's a number like OE header, UID. If anyone has queried P21 tables, most of the tables have a UID field, except invoice does not have a UID field. Interestingly enough, the invoice number, which is a text string field, is a primary key, and it's non-numeric, it's alphanumeric. So invoice table is a table that can cause a lot of slowdowns. If you're running sales history queries, you want to query the invoice table. I came from an organization that I worked in IT at, and the invoice table, I don't know, they were invoicing probably 600 orders a day on a slow day. So that's a lot of records. And over time, you get users that want to run a sales history report for an entire year. And now all of a sudden you're pivoting that data. Um, so it becomes a stall point because the invoice number is a non-clustered index. So its table performance is always going to be a little bit slower than it might be on the OE header table, just because of the circumstances of the index. And one of the tools in SQL Server Management Studio is the query plan estimator. And before I get into that one, I'm going to talk about another thing that I forgot to mention that a lot of users have experienced that are going through the whole P21 upgrade process is the cardinality estimator. The cardinality estimator is this little essential tool in SQL Server that basically tells the SQL Server how many rows are in a table. And the SQL Server Query Optimizer, which is the tool that basically optimizes the SQL Server queries, it's a cost-based query optimizer. In other words, it looks at each step in a query, whether it's a join or an operand, like a equals in a where clause or greater than, less than, looks at all of those pieces in a query and breaks them down into a cost. And you'll see how all these things are interconnected. And once you understand how these things are all interconnected, because the cardinality estimator is and the optimizer are cost-based, it looks at a query, looks at your SQL query and says, what do I need to do this? Well, it has to go and grab a bunch of rows to estimate how I'm going to go about building this query to get the information that the query is requesting. And it looks at each of those points in the query and calculates out a cost. And then it adds up that cost. If that cost is beyond your cost threshold, then SQL will go parallel when it's executing that query on the fly to say, I need more help to run this query. I can't do it with a single processor. So I need to go parallel. So you'll see how all of those little pieces are interconnected in SQL Server. That cardinality estimator is a feature that, well, Microsoft has been evolving SQL Server probably faster than a lot of applications running on SQL Server have evolved. In other words, using keywords, built-in functions, all of these things that are part of the SQL Server database engine that are tools to use, all factor into that cardinality estimator. And if you're building an application and you're using some of these tools that are legacy, and Microsoft is moving their SQL Server version ahead, you may have to set your compatibility mode lower. And up until recently of 23.1 for P21, they were recommending that if anyone was on SQL Server, like I think it was 2016 was the cutoff, that you should run it in compatibility mode for 2012, because the cardinality estimator, if you turned it on to be the newer one, was causing queries to perform poorly. For example, search windows in P21 may perform poorly. Some of your own queries may perform poorly. But when you're writing your own queries for your own reports, you can influence that decision-making process. And you can actually set those boundaries at the query level. You can even with what's called a SQL hint, or you can set it at the database level. So on mine, I'm running mine on SQL Server 2017. But if I was to look at a database under here, and when I'm saying compatibility level, you're going here to options, and you're looking at compatibility level, I'm running at 2017 or 14.0 or 140, they call it. And I'm going to show you on the one of the things that I had a lot of queries open ready to do some things here. So there's an execution plan estimator functionality that is a very, very useful tool in SQL Server. There's two tools if you're a SQL developer, and as I'm sure the Jedi Masters will use this all the time, and the Jedi Knights, is SQL Server Profiler, which is a little sneak peek tool to see what queries are running against the database at any given time. It will tell you the query text. It'll tell you the application that's running it. It'll tell you the process ID that's running it, the user, excuse me, it'll tell you the user that's running it. All kinds of information that SQL Server Profiler. It launches as a separate tool under here, and you'll launch SQL Server Profiler, and you can profile any queries that are running. This is an indispensable tool, and I use it all the time working with clients to find when something is running, because there's just so much going on in P21 application that it's hard to tell, and you have all kinds of filters and column filters, and you can tell it what you can filter on specific things. The caveat that I say to people is, if you're running this against a live database, try to do it after hours or when there's a minimal number of users logged on, because it will impede your SQL Server. It can do it significantly. Another one is, like I said, the execution plan estimator. So there's some functionality up here. You'll say display estimated execution plan, include actual execution plan. So if I click this and I highlight this query here and I say execute, it's going to tell me my execution plan here, and it tells you a lot of information. And you look at this and go, oh my God, what am I looking at? The key things that you're going to want to look at is the estimated IO costs, or the operator costs, subtree costs, the number of row reads that it had to do, because in here it tells you little pieces of information, and you'll notice I'm querying the invoice table based on a filter here, and it's telling me, I keep hovering over that, the saying that the operation that it performed here was a index scan of a non-clustered index. And you'll notice here a better one would be if I go to another query here. And if I say this one here, you'll notice here there's a lot more steps in this one. This is the column store index scan. You'll see here that this is a non-clustered index. All these are non-clustered index scans. But the fatter the line between each of these steps, it's basically telling the estimator that it had to bring back this many rows before it could determine if it was going to bring back everything that the query actually requested. So out of several 100,000 rows, it had to bring back 251,000 rows. It's estimating that it's going to bring back 251,000 rows to execute this query. So that in itself consumes time. So these are things that you can look at. And then what happens is you'll actually see here when you run this, if I run the actual estimated plan, it didn't give me the error warning message this time. A lot of times if you're querying the invoice table and you want to run the execution plan against it, you'll see a little green warning here saying maybe it's recommending to you to add a clustered index. So it sees the invoice table and says, hey, gee, there's no clustered index on this table. We really could improve the performance of this. So one of the things you might consider is if you were building a custom report, you may want to create an invoice table off to the side if you're always reporting on it and add a clustered index to it and call it invoice header UID number or invoice number UID or something like that that's a clustered index. If you're always querying reports, you could significantly improve the performance of your query. Another thing that you might consider if you're building reports is oftentimes table variables. You can use table variables. You can add an index to a table variable, which is just a temp table that only runs and exists for the length of that query session. And then it's disposed of. They're super fast. And oftentimes now in versions of SQL Server going forward, they have optimized table variables. I believe in 2017, they really started optimizing them. In 2019, 2022 is out now. They've done a lot with memory optimized table variables, memory optimized tables, where you can actually run a table in memory and query a table in memory. It doesn't even go to disk. So you could have massive reports if you've got, I've built inventory forecasting reports that do a lot of data pivoting and unpivoting. They really do a lot of data grinding. You may want to investigate using table variables, memory optimized tables inside of those types of queries. What you really want to work on is if you're doing a lot of reports, you may want to consider building SQL views. You'll notice in P21 database that there is a view for pretty much every table. And a lot of times the views actually have more information in them. Case in point, I'm targeting the invoice table because it's such an easy one to target. The invoice or P21 view or sales history report, which is pulling the invoice tables, has a lot of other columns that you can query that view, which is already an optimized view, instead of building your own query against invoice header and invoice line and joining those tables. You may find that actually joining against the view on invoice number, if you're just adding some other field, might actually improve the performance. a brief word on SQL operators. Try to minimize. I tell people try not to use select distinct if you don't have to use it. Um, it's a buzzkill on large queries. It can be a buzzkill on performance. Um, count star, also bad. Um, you can do things like, back in the day, I come from an electronics background. You were taught Boolean algebra, ands and ors. Try to reduce the number of logic gates. I've seen a lot of queries where people put a lot of ands and ors in their where clauses. Try and break it down and reduce it because SQL does execute those in a specific order. I think it's ands before ors. So if you've got nested ands and ors, you want to try and reduce those filters. Um, I like to use common table expressions. Some people like to use derived tables. Um, and if you're not familiar with what those are, I wish I could go on forever. I could go on forever. I could just literally talk for hours and hours and hours and hours. And SQL can be a lot of fun, but it can also be very frustrating at the same time. That's a very, very powerful tool, has a lot of tools built in it to allow you to do just about whatever you want. I mean, you can even connect to APIs in SQL Server now. It can handle XML, JSON, um, all kinds of stuff. They're not very performance effective, but one of the things I found in my years working with SQL is the query optimizer, plan estimator is a useful tool. Um, the DMVs, very useful tools. I use them all the time to see. You end up getting and to one of the other Jet presenters' points is you start building a repertoire or a stash of queries that you can run. You just go in and you can quickly find and target problems. Like a lot of the DMBs queries that I built over time just are little quick onesies that you can go in and run against, you know. Uh, Another one here is this will check your index fragmentation. I've worked with clients that say, how can I tell if my indexes are fragmented? I don't know if my maintenance plans are running well. Updating statistics, updating indexes. I've seen a lot of maintenance plans where you've got the update statistics and reorganize indexes all in one maintenance plan task. Break them out. Same with the backups, transaction log backups, database backups. Obviously, transaction log backups should be done as often as you want them. If you had to do an emergency restore, um, something happened catastrophic in the last 20 minutes, but your company puts 1,000 orders in like a half an hour. You may want to say, well, my SQL log backups are going to happen every 15 minutes. Well, people go, that's a big performance impact on SQL database. No, it's not. It's actually worse if you wait for longer intervals because it can put locks on certain things on the database. I found that you want to try and kind of get a happy median on when you're doing the log backups. SQL backups, obviously, every day. Statistics and indexes. If your indexes are getting out of joint that badly every day, there's something bigger going on behind the scenes that you may want to consider investigating. Updating statistics and updating indexes and defragging, reorganizing your indexes, whether you're using Olin, Hallengren's optimization queries, you've written your own, I've written some simple ones, or you're using the built-in canned maintenance plan strategy in SQL, which is solid. It works. It's limited in its feature set as far as choosing threshold levels and stuff like that. Um, but you should only be really running those maybe once a week, twice a week at most. Running them every day, it doesn't add a performance benefit. And the reason being is you can tell SQL Server to defrag the pages of the indexes and pages of a table all you want. It's still going to base it on there. It has its own built-in threshold logic to say, you know what, there's only 50 pages to this table. Why am I defragging it? It's a waste of my time. Move along. And it'll just go and pick on bigger targets. Now, when you're talking 2,500 tables or whatever the number of objects is, there's a lot of tables in P21. You're just telling it to do something that it doesn't need to do. I typically would look at and say, okay, here's an example of a non-clustered index on, I didn't order this in any specific order. I guess I should have on that table, but you look at this and say, oh, it's only got 745 records in it. It's the number of pages is 11. That's nothing. I mean, it's not even worth, even if that was 90% fragmented or 99% fragmented, it's not going to offer you any performance gain. Typically, the threshold before the user experience would start to suffer, and I can attest to this because I've done many different tests in the past, trying to squeeze every little bit of performance out of a SQL Server as you possibly can before you call the mercy rule. 25 to 30%. If it's anything less than that, nobody's going to notice. That's kind of the threshold. If it's 25 to 30% up to, no one's going to notice a performance impact. When you start going above that on tables that have large record counts, whether it's clustered indexes or non-clustered indexes, you're going to find that you might start to see performance degradation. But P21, 23.1 has, they've done a lot of improvements in how fast it queries stuff. And we've done a lot of work with clients on earlier versions of P21 to really tweak and performance tune their database that when they actually get to 23.1 is going to be, light speed, pretty much the hyperdrive from the Millennium Falcon. So there's lots of things you can do to throw performance at SQL Server, but if the application that's running on the user database is poorly tuned and inefficient in its queries and how it queries the data and how you organize the data and how the table structure is built on SQL Server, it isn't going to add any benefits up to a point. There is a threshold. And plus licensing costs for SQL Server to say, I want more cores is not necessarily a benefit to you. Performance tuning your queries, though, and using these built-in tools like the estimated execution plan, looking at what that really is, what it looks like, interpreting it, run two queries side by side, you can really start to see where your queries are suffering, where you can tune them. There's lots of information on the internet on these tools. I've learned things as I've gone along, to be quite honest. And you end up finding a need and you figure out the how to do it, when you need to do it. Don't let things get so bad. It's easier to learn the best practices sooner than later, before it becomes a problem. I find there's different ways you can tweak your query logic. One of the steps I often tell people, I look at a query, and I've worked with a client that we did a bunch of SSRS reports for, and they come back and say, I've looked at them and said, some of this query logic is older. It's not optimized, and the more data you get, the slower these are going to run. So now it's a end up circling back around to try and performance tune some of the reports and rebuild the queries and tweak the information in the queries so that you're getting rid of some of the joins, possibly you're using nested tables, maybe you're using a union instead of 20 joins. You're going to break it out into a couple of union selects where you're bringing back records. Um, One of the places to try it is really use these tools. Like I did this example here. This is 3 unions bringing back the same information that this table brings back the same information that this query brings back. These are 3 queries written 3 entirely different ways that bring back the exact same information. That SQL Server may choose to write a different query execution plan for each one of them and tell you, I'm executing this one this time this way. Um, and there are ways to actually force SQL Server to keep reusing the same query plan. If it looks like it's the best one, you can add a hint to it to say, use this query execution plan every time. And just another note, and then I think we'll break to questions, because if I keep on going, I'm just going to go right on over and to bedtime, and everyone will just drop off and I'll be the only guy left on the call. But if you click on this as an example in the execution plan and I highlight the select, actually, I have to rerun it this way. And if I click on here, it will actually tell you the competitive cardinality estimator mode version here. So it tells me that I'm running 140. So I should not have any problems with any of the P21 versions running on in SQL Server 2017, where I run into errors and stuff. If you do, then you may want to turn the compatibility mode back. But I can tell from this execution when I executed it that I am clearly running this compatibility mode. And it tells me every statistical piece of information I could ever ask for on that. And it tells you basically the cost. So I think on it there, those are the really ground level kind of key points, touching points on how you can optimize SQL Server and how you can go look for the hints or the information if you feel that it's not working to optimum performance. There are the tools right in SQL Server Management Studio. You don't need to go buy other software. You just need to know how to use the tools that came licensed with the product. And once you figure out this and start playing around with it, it's a rabbit hole you can go down. It can sometimes take hours to investigate, find problems. We've often found issues where you're trying to help other support techs to get a query that finds when an error is actually taking place under what user session. So it's how do I go about finding that? Well, you might use SQL Server Profiler. You might use some of these tools. You might want to do a trace on the SQL query executing itself. You may do multiple things. So those are all just really good tools you can use at your disposal. So I think I can end it there, and I'd rather take on a lot of questions if there's a lot of questions. And if not, no, I scared everyone off.
All right there, Brad. Looking here for some questions, and still have plenty of people in the attendee booth here. So if any of you Padawans or younglings, or even if you're Jedis out there, have any opinions, by all means, raise them up here. So, Brad, when you're working with SQL as it is fronted by, say, reporting solutions like SSRS or even, say, Crystal, what's the best way if you're doing, say, a Crystal report inside of P21 to be assessing its performance? Because I've seen, in the past, Crystal reports have had, at times performance issues. What's the best way to go around trying to tighten one of those up?
Yeah, so Crystal reports, there's multiple ways you can get queries into Crystal reports. You can put the SQL query, SQL command in the report itself, which will just get passed as a string to SQL Server. You can actually create a view in SQL Server if you have access to it. If you're SaaS hosted, you're left with using the views that are exposed to you to use. So there's really no option to performance tune those other than um, just making sure your query logic is good and you don't have any of those tools at your disposal um, to look at them. But I do believe actually in Azure Data Studio, to that point, has a query plan um, visual tool that you can run. I've actually never tried it against Epicor SaaS to see if it actually executes, but you would probably use SQL Server Profiler, run the report, see the query that's actually being executed using SQL Server Profiler. Um, then you would take that query and stick it into SQL Server Management Studio and maybe actually run through these steps where you would look at the execution plan itself, um, maybe dissect into it a little bit more, see if it can be performance tuned, or um, you might want to try building a report a different way that groups the data a different way. Um, for instance, I'll use the blind example, select star versus selecting actual column names, right? You want to, if you're not needing the columns and you're not needing that data, remove it from the query. I know a lot of people have written large queries where they've got all the data in there. They actually comment out the fields, but they don't actually comment out the joins. Well, SQL Server is still going to use that join, um, and it may impede its execution performance. So if you're not using any of those columns or rows, then go back through, make sure your SQL logic is always as clean as possible. Get rid of any superfluous things you're not using. Save it off as a version if you want. I usually do that where you save it as a version and then you keep the most current one, the cleanest one on the report itself. But that's the way that I would sort of reverse engineer to try and troubleshoot if there's a performance problem.
Right, right. Another question. When you're writing a report of any type here, I've seen cases where a report will get written and it'll end up with a lot of filtering done post query, I guess is the way of putting it. So you'll get a big data set returned, and then the reporting tool will filter that down to present it. So you end up with some pretty big data sets being passed. Do most of the P21 reporting options allow for a degree of parameterization so that those filters run on the server and don't have to get passed back, in a big data set?
Yeah, so good question actually. There are multiple ways that I've run into over the years on that is to sort of I always use the terminology let SQL Server do as much of the heavy lifting as you can because it's optimized to bring data back from a relational database already, where um, a lot of these reporting tools are multi-pass reporting tools where it will go actually and get all the data first and then run your filters on the report to clean it up and filter it. So to your point, yeah, that is a that your report can actually take a performance hit.
Mhm.
If you can pre-filter it at the database side first in the query, that's usually the better option to increase the speed. What I've even done in the past is A quick example that I just recently did was rebill invoices. P21 stores the rebill invoices in the same table as the invoice. So how do I know what was the last rebill invoice that's attached to, because you could have a rebill of a rebill of a rebill and keep cascading it till the Jedis come home. But the what it ends up doing is giving you false positive information. So what I've done in the past is you put all of that into a temp table in your query, get all that information in a temp table first, and then query against it. It's much faster.
Mm,
Because you're indexing it, it's already in a table. Now it's gone and gotten that very specific information. Now I can query or join against it. I've got a fresh index that was just organized and built. And now I'm querying against that index, and SQL will, it actually, I've done that in queries where you've literally knocked off 75% time. It's
nice.
crazy. You would think it should run the same way, but it doesn't. It actually will recompile it and run faster.
Hmm, excellent. Now, if you're asked very generically in a P21 context to provide a report that does something, um, do you have a set of tools that you would prefer to use before? Do you have like a portal, then Crystal, then something else? Do you have like a triage or a decision tree that you go to if you're just being asked to return data?
Because I love working with the tool, I'll always ask clients if they've got availability to it. And if they're, say, in our Echo, I know they do, is SSRS,
Hmm.
because you can use Microsoft's integrated development environments like Visual Studio to actually build SSRS reports and do some really cool stuff with them. Even BI, you can use a lot of these tools and build these reports out. Um, Infomaker Infomaker portals, well, they plug into P21 for the most part nicely. And what I mean by that is once you test your database connection and everything else, P21 will pretty much take over that connection and use its own session connection and just run the query and the report, and it plugs into P21 relatively easy. The design tool is where the limiting factor is on that. It's the archaic, it's not a very user-friendly design tool when you want to do very sophisticated reporting things. Like it's just not. Um, Crystal reports is not a lot unlike SSRS, with the one exception that SSRS is 100% web UI all the way. It has its own web server services, where Crystal Reports is there's a lot of report executing software out there. Even there's open source stuff. You can generate a Crystal report and view it and compile it as a PDF, or you can use the web version of Crystal Reports, which is a Crystal Reports server, which is not licensed by Epicor. It's a separate license, but it will do the same thing as SSRS. Either of those tools are extremely powerful. I just prefer, it's what you prefer and what you end up getting comfortable writing in. I like writing with SSRS because it does plug into P21 quite well with the web UI. Actually, it's a really good tool. So
Excellent. All right, we did get one question come in, but it was not especially technical. It says, as a Padawan, I glazed over at some of this, but it's important. Will slides or some other reference to this be available for study? And the answer to that is yes. What we're going to do, we're going to take this recording and deploy it to our YouTube page. So when that's done, we will send some emails with links out to the attendees so that you can follow that up. And if you need to have a second look, you'll have that ability there. So with that, Brad, I think we're out of questions. So I'm going to release you for this session here, and we will start our break with one more session coming up. Our last session is going to be on the subject of the web UI and the migration that customers have been making towards that web UI. So that will be what we'll cover when we get done with the next 5 minutes block. So let's plan to circle back in 5 minutes and we will then jump into that.